welcome to another lesson with our flipped classroom on quadratics. Today we are going to be looking at problems and applications of quadratic equations. That means putting on our problem solving caps and having a look at word-based equations to figure out how to solve quadratic equations. Now, for those of you who struggle with this, we're going to go through a few steps on how to solve word-based equations, but since we're not really learning anything new, today's lesson is going to be fairly quick, and so we're going to jump straight into our examples. Okay, example number 1. The distance travelled by an accelerating car is given by the formula d equals 3t plus t squared, where t is the time in seconds and d is the distance in meters. If the distance travelled was 130 meters, for how long was it travelling? Now I find it interesting and appropriate at this point in time to start highlighting the important parts of this particular question. So first of all, the most important part of this question is the equation. The second most important thing is the fact that it tells us in the very last sentence that the distance travelled was 130 meters. Now that's relevant because we were told that distance is represented by the letter d. So I can substitute this number into our equation. Now that's going to change things slightly. That means instead of d equals 3t plus t squared, I'm going to get 130 equals 3t plus t squared. Now remember, to solve a quadratic equation, we need to move everything over to the same side. So I'm going to move the 130 over here. That will give me the equation t squared plus 3t minus 130 equals 0. Now that I've got my quadratic equation, I can try and factorize it. By trying to factorize it, remember I'm looking for factors of negative 130 that add together to give me 3. Now the most obvious one that I'm thinking of right now is 10 and minus 13. Or, if we flip the negatives, minus 10 and positive 13. Now let's see if either of them add together to give me positive 3. So 10 and negative 13 give me negative 3. So not that one, but this one should. Minus 10 plus 13 does give me positive 3. So that means my quadratic equation becomes t plus 13 and t minus 10. And that equals 0. Now solving this, it means that t either equals minus 13 or t equals 10. Now because these are word problems and are based on real life stuff, we need to make sure that our answer actually makes sense. So let's read the question again. The distance travelled by an accelerating car is given by the formula, where t is the time in seconds and d is the distance in meters. If the distance travelled was 130, for how long was it travelling? So the gist of this question is we're trying to find time. T for time. So looking at our two answers, we've got minus 13 and positive 10. Do both of these answers make sense? Well, if we try and think about it logically, we can't really travel a distance in minus 13. We can only travel in positive direction. We can't go back in time. So having an answer of minus 13 seconds to travel 130 meters doesn't make sense. So in reality, when we solve this equation, the only logical answer must be that t is equal to 10. And that's something that you'll need to point out. If you finish your answer saying that t could in fact be minus 13, you'll be marked down because, well, t can't be minus 13. You can't travel negative 13 seconds over a distance of 130 meters. So that's another sticking point that you'll need to make sure that you pick up as you go through these word-based equations, because since we're dealing with quadratics, you'll always get two answers, and sometimes not all of them will make sense. So you need to make sure that you highlight or make a small statement saying this one does not make sense. Okay, example number 2. when the number 10 is added to the square of a positive number, the result is equal to 3 times the number subtracted from twice its square. Find that number. Okay, let's start finding some mathematical operations to put in with our words that we've got in here. So first of all, we've got the number 10. So 10 is added, okay? So addition to the square of a positive number. Now we don't know what that number is, so let's just call it x. So the square of x, or x squared. Now the result, or equals, it is equal to 3 times the number, so 3 times that same number, or 3 times x, subtracted from twice its square. Now there's two ways that we could write this. We could write 3x minus twice its square, 2x squared, twice its square. Or we could write 2x squared minus 3x. Depending on how this sentence is written determines which one of these two it is going to be. Now the terminology is very crucial because with subtraction, the two different ways we have these terms gives us a completely different result depending on which one you subtract from the other. Okay, let's read it again and try and figure out which one it is. So it's equal to 3 times that number subtracted from. So this 3x is subtracted from twice its square. So because it is subtracted from, it means that it has to be this one and not this. This is the wrong way around. So with word equations, it's important that you don't just read from left to right and assume that that's the order of things. You need to use comprehension skills to make sure you understand the order of which these terms are going. Okay, so this is out of the equation. So our example is actually 10 plus x squared equals 2x squared minus 3x. Now to solve a quadratic, we need to remember that everything has to go over to the same side. So let's first of all subtract x squared from both sides. So that gives us 10 equals x squared minus 3x. Then we'll take 10 from both sides, so that x squared minus 3x minus 10 equals 0. Alright, now we need to start solving our quadratic equation. So let's see if we can work it out like in number 1 by finding factors. So if we were factorizing this, we'd be looking for factors of minus 10 that add together to give minus 3. Now if we try that out, well, factors of minus 10, we've got 10 and minus 1, or minus 10 and 1, or we've got 2 and 5, sorry, minus 5, or minus 2 and positive 5. Okay, so looking at these, that's out. That's out 2 and minus 5. Yes, that adds together to be minus 3. So that means our factorizing becomes x plus 2, x minus 5 equals 0. So that means either x could be minus 2 or it could be the number 5. Now let's have a look at our example and see if both of these answers make sense. So we're looking for a number which is added to the square of a positive number. Basically we're looking for a number. It's not relevant to time, it's not relevant to acceleration or anything like that. It literally could be either of those two numbers. If we put this into our equation, it would work. So in this example, both of these are legitimate answers because it's not based on a real life scenario with positive and negative numbers. So when doing these examples, like I said before, it is crucial to analyze your results because you're always going to get two answers with quadratics to make sure that both of them make sense. In example 1, they didn't, but in example 2, they did. Very important. Now, problem solving was a weakness of mine when I went through high school. So I'm assuming that there's going to be a couple of people that don't like doing word problems, and so I encourage you to make sure that you come and see me in class, and I'll try and use some of the hints and tips that I learnt over the years to help me cope with some of these problem solving questions. Anyway, that's it. I hope I've been able to give you a bit of an insight on how to solve these types of quadratic equations, and as always, I'm Mr. Rappell, and I'll see you guys again.